Okay, so for this video, we are going to end up needing the, because we're going to want to calculate estimated sum of squares and residual sum of squares. We're going to end up needing the predicted values for each index of x. So what we're doing with this is we get this set. We can simply call this y hat. But these predicted values are taking our formula, yi equals 1.3 plus 0.9x, and it's just plugging in x's and then getting these values here. So you'll notice that these values differ from the actual observed y values, and that's kind of the key to everything. That's sort of the whole reason of doing what we're doing. So that being said, if we take, okay, x times 1, that's because the first x value is 1. So for y1, that's going to equal 1.3 plus 0.9 times 1. Because our first value at that index of y1 equals x equals 1. And so this ends up being 2.2, if I'm not mistaken. Yeah, 2.2. And then I'm just actually going to kind of burn through these. So same process. I'm going to do one more. So y2, y index 2, we come over here. X is also equal to 2 on this list. Plus 0.9, x equals 2. And this ends up equaling 3.1. So we put 3.1 here, and you just do that for each line item. So here you would insert 3, x equals 3, because that's what it says. X equals 4 here, and x equals 5. It just happens that in my data set, the x's coincide with the indexes, but do not get confused. If x was 15 at index 5, then you would put 15 here, not 5. So it just happens that x is equal to 5. So don't get tripped up by that. Then I'll fill out the rest of this. You can do this on your own. It'd be good practice. Otherwise, just to kind of, turn and burn numbers. The more time you spend with data and just, repetition, the more this stuff actually really sinks in. So don't be shy about doing a little too on your own. Now, and when we actually really get in deeper into the econometrics of this, I do anticipate that I'm probably going to start throwing like multiple examples at you that you can try on your own. That I do think is going to be more my goal for it. But when we're kind of covering this quasi-statistics, quasi-basic stuff, then I just want to end up having you guys burn through this with single examples, and kind of using all the same data as much as possible helps kind of connect the dots, I feel, to one another. So ESS is the first thing we're going to want to calculate, and that is going to equal the sum of the y hats and their difference with their means, the y bars. And so that's going to end up equaling, and I'm going to do this in 2 columns. So this is y hat minus y bar, and then this is that same thing squared. So it's just what's inside of their square. And so we'll start with these. So we've got 2.2 minus 4 equals negative 1.8. It's negative 1.8. And then we have 3.1 minus 4 equals 0.9, negative 0.9, excuse me. Then we have 4 minus 4. You can throw that away. All of this is just going to be equal to 0 on that line. Then we have 4.9 minus 4. And 4.9 minus 4, again, is 0.9, but this time positive. And then 5.8 minus 4 is also positive at 1.8. And so then we just take these values, so negative 1.8 squared. And remember, we're summing these. So plus negative 0.9 squared And then 0 for this, you could say adding 0. And then we have 0.9 squared, and that's being added. And then we're adding 1.8 squared. These guys are going to sum to, so once you sum all of these values, well, actually they're going to equal 3.24. This one's going to equal 0.81. Sorry if I'm in the way here. 0.81, 0. This is going to equal 0.81. And this is going to equal the same at 3.24. So we're adding all of these together. 3.24, 0.81, 0.81, 3.24. And so as we add them all together, we end up with 8.1. So that our ESS, we now know, equals 8.1. So we calculated that. And this, again, that's just the sum of all the variation that is explained by the line of best fit that we created. And then finally, what we want is the residual sum of squares. And so I'm going to erase this, give you the formula for the residual sum of squares. And then we'll be able to play with those numbers just a little bit and close out. So the residual sum of squares is going to be, the formula for that is y, just regular y's, minus y hats squared. And this should make sense. So, initially we were using the means because we're just trying to measure things being pulled off of the means. But now with the residual sum of squares, we're literally just trying to explain again the sum of those differences like we were talking about last time. Those distances, we're trying to get an essence of the distances of magnitude of our data points off the line. And so it's telling us, hey, this is how much isn't being explained by the line itself, because it's a sum of those differences off the line. So the line is what our model would predict, and the points off of the line are what the actual data are showing us. And so that's the reasoning behind this. And then comparable process that I'll do to the last thing. I'm going to do this again in just 2 columns. So we'll do this and then y minus y hat squared. So I'm just making it 2 columns so it's easier to see, but we are summing this column when we finally calculate that. So this is going to be 2 minus 2.2, and then that's going to equal, we'll say, negative 0.2 squared, and then that'll equal 0.04. And so that's the first value we're summing. This is going to equal 3 minus 3.1, which equals negative 0.1. And we're squaring that. It's going to equal 0.01. And then we're adding this. And then we have 5 minus 4. And that becomes 1 squared equals 1 plus, and then 4 I'm getting ahead of myself. So we got 4.0 minus, I tried doing it again, minus 4.9. This is going to equal 0.9, negative 0.9 technically speaking, squared. Note that it makes a difference when you're squaring these things as long as you get the numerical value right, but it is good practice to not do that. That's what does me in a lot, is sign errors, and I get lazy with it. So forgive me if I think you'll notice when I make mistakes, if I'm making them, the more frequent ones are the sign error ones. I think that's probably true of a lot of people too. So this is going to equal 0.2 positively squared, and then this is going to equal 0.04. And so when we sum all of these up, you're going to get a value of 1.9. You can double check me on that, but I did sum that a few times. Now, we have, and that's our RSS. Another way you can use these to double check each other, that's nice because this relationship always holds, with the total sum of squares equals the estimated sum of squares plus the residual sum of squares, is just make sure that that's actually the case. So we know this equals, TSS equals 10, and so all we have to ask is 8.1 plus 1.9, does that equal 10? And it surely does. So we know we have the right values from just that expression alone. And then finally, I'm going to throw you the R squared formula, or throw at you the R squared formulas again. And yeah, I erased the TSS, but hopefully you've seen it, that it was 10 long enough. You probably will remember that. And then we have 8.1 and 1.9. So R squared equals, we can view this in one of two ways. This can either be viewed as just ESS over TSS, or it is also equal to 1 minus RSS over TSS. Both are equally valid. And again, this would be in this form. We have 8.1 over 10. That's going to equal 0.81, or actually, it is 81%. I keep wanting to just approximate, but it actually is. Usually, most time when you're doing these, you are going to be writing approximations. But we can say the same thing here, so it's 1 minus 1.9 over 10, which equals, basically, we could turn this into a fraction, 100% minus 19% equals R squared. And that's literally the same thing. But yeah, that's just two forms that we can write these out. So hopefully you found that useful. And I think that wraps up what I have for you on this stuff. We are going to be living in this land here very shortly. So keep this in the back of your minds. This is important when we start really jumping into econometrics now. First things first, like we're gonna be talking about things like their degrees of freedom, and then F statistics from there that we'll sort of build off of. So, got a few introductory things kind of to go through yet, but hopefully it'll feel just pretty organic. The only video I'm going to have in between this is just it'll be brief. I'll just want to be talking about the various styles of econometric data, and then we'll jump right in.